About two-dimensional kinematics. So we're going to start with a standard projectile problem, maybe two of them, and then I want to go to a non-standard projectile problem. If you've forgotten, what I mean by a non-standard projectile problem is one in which AX is non-zero. So for standard projectile problems, they can have uneven ground, but you always have A sub X is equal to zero. Gravity is the only force, free fall, we ignore air resistance, things like that. So we're going to start here with 4.12. So I'm going to go ahead and get this written up on the board behind me. You start writing up what you think, how you would start the problem. And most of the physics learning happens in the setup to these problems. So imagine you're trying to solve part A here. Think, what should you write on the board? I'll write what I think you should write on the board, and we'll compare in a minute, okay? Oh, almost lost the headphones there. Okay. I'll line up the whiteboard afterwards. 4.12, page 74. Looks like we got some kind of a building here. Some kind of a projectile here. Now the height of this building is h. Okay. There we go. So I haven't completely finished here, but this is a start. So I started drawing this thing, and I was reading, we're trying to get the speed at impact. So remember, for a physics problem, that really means the speed just before impact, the nanosecond before it hits the ground, right? So here's that ball right before impact moving this way. And so maybe I'll write that up here. I always like to stress whether I mean speed or velocity, and I try and do that in the solutions as well. Yeah, this says speed at impact. So to be clear, am I looking for V final X, V final Y, or V final? What do you think, class? Somebody can go ahead and unmute.
Final.
That's right. So as tricky as this is, be aware, together, the speed and the direction make a velocity. If I just say speed, I'm asking what is V final? Velocity is V final. So different, right? So watch out. V final is speed. V final is also velocity. And remember that in these problems, you kind of have to know whether I mean a velocity or a magnitude. And the key word here is speed. That's the magnitude of the velocity. All right. So next step would be writing up Oops, I'm running out of room. I guess I don't need t. It's the same time. All right. And so I know you guys could read the solutions or whatever, but I mean, the whole point of having a class is to try and interact a little bit. So I'm asking that you maybe be brave here and take some chances. And if possible, make some mistakes now that you won't make on the test. That said, so I'm going to ask you about each of these things and see which things you know. And in particular, if you don't know what something is, just say unknown. Okay. If you do know what it is, tell me what it is. And remember, these are the variables that we're given. All right. I don't think we were given these in the original picture. So in this case, does anybody have something for delta x? What do you think delta x is? Or delta y? One of these two. Does anybody know delta x or delta y?
Delta y is negative h.
Negative h. It's not h because you go downwards h. So remember, on every single thing in here, there's an implied j hat. So you got to remember, oh yeah, it's the distance is h. The displacement vertically is negative h. Good job. Do we know what x is or is it unknown? I think that was Esteban, right? What do you think, Esteban?
Yeah, that delta x is unknown.
Okay, I agree. All right, somebody else. Any of these other things? I guess I should be clear. These ones. There's an I hat on all these ones, right? Okay, so somebody else. Anything else in this chart? Just tell me any one of those things that you know or don't know.
Is V initial X and V initial Y V?
Careful. How much is this thing going up and down initially? Whoever that was, I don't even know who it is. You shoot this thing horizontally. So how much is it going up and down if you shoot horizontally initially?
No, is V initial Y 0?
That's right. And so what is V initial X? That I think you said correctly.
That was a V.
Yeah. So the idea here is another way you could think about this, the launch angle, which is theta, is 0 degrees. Now be careful, launch angle theta and impact angle phi are not the same symbol. Theta has a horizontal line, phi has that kind of slanted vertical line. So yes, if you plugged in 0 degrees, right, you may be thinking, wait a minute, isn't V initial X supposed to be V initial cosine theta initial or whatever, theta? Well, cosine of 0, that's just 1. And V initial Y is V initial sine, in this case of 0 degrees. Well, that goes to 0. And so notice we do get exactly what whoever that was just said. So nice job. I don't know who that was, but good job. All right. Any questions on that before we go on?
I'm kind of confused on how you got
All right.
zero.
Say again. Something cut out.
I'm kind of confused on how you got 0 for the degree.
Oh, in math, isn't that a 0 degree angle
Oh,
straight
yeah,
to
yeah,
the
yeah.
right? And
Yeah.
so if I look back in the, I'm assuming that's 0 degrees from a math class. Yep.
Mhm.
Good job. All right. Good question. All right. Let's skip down to the A's. What are the acceleration in the X and Y? Oh, that's supposed to be an X, isn't it, right here? It kind of got sloppy. This is supposed to be X, and this is supposed to be X. What do you think?
What you got for x is 0 acceleration because it's standard,
Yep,
and negative g is the acceleration on the y-axis.
and that's correct. Remember, G is the 9.8, the negative cos negative J hat. All right, and so, by the way, when we do that, we're basically assuming this coordinate system right here. we're assuming that's the x direction and that's the y direction right there. So I got to scoot this closer, and I'll angle this a little bit so you can see it a little bit better. So again, unless otherwise specified, usually x is to the right and y is up. Unless there's a really good reason to not use that, we're going to always use that. Okay. There are rare exceptions. All right. So somebody else, what does that tell us? Do we know anything else here? We got 3 things left. I expect that at least one other thing is known. Usually we end up with 3 unknowns in a 2D problem.
V final x is v.
Oh, yeah, you're right. That should be a V final right there, shouldn't it? Thank you. And how do you know that, or what's kind of your logic, or what do you think?
Since it's not accelerating, v is constant.
If this is no acceleration to the x, these two have to be the same. Nice job. So then you could bet these other things are unknowns. At this point, reread the problem. What are we looking for? Speed at impact. Huh. Now I'm going to erase this just so I have a little room here. How do I get the speed at impact? Well, I notice over here, V final would be this by the Pythagorean theorem. If I need the angle, that would be tan inverse of V final y over V final x. Let me get just a little bit more there. Okay, scoot it back just a hair. Okay, and so I think this is what part A was asking. I think this is actually part B, but yeah. So you could see, and I would guess the critical issue here, since we already know V final x, we need to figure out V final y and use that to get these pieces of information for parts A and B. Any ideas what we should do next? Somebody, Esteban's answered a couple times already, so maybe somebody other than Esteban. What do you think? Somebody new? What's the standard thing we do next after we write all this crap down?
Write down equations.
Some equations. So I got to scoot this back now. So in this case, you could beat me to the punch here. Need some space. I'll number these 1, 2, 3, 4. Our 4 standard equations. I think I can make them a little bigger here if I scoot forward a little bit. So in this case, and remember, at any time, if I'm going too fast, you could send memo, a chat message or something. All right. Which equation jumps out at you? And there's many correct ways to do this. Or I don't know. What would you do? There's lots of different correct ways to approach the problem from here on out. There's many different things you could do next. What's something you might try next? Anybody?
I normally go with the VF squared because that's like the only one I have memorized.
Yeah, it's funny, right? You use that one a lot. So he says VF squared. Okay, so if we're going to use that, let's plug in what's 0 in that equation. It looks like I know the acceleration in the y, It looks like I also know the change in y. So I should be able to get this right here, right? So that to me looks like a good plan of attack. So I need space because this whiteboard's tiny. So I got to erase everything and get to it. So we just saw it's 2 Now, that was again because the initial y was 0 in this problem. So now, if I plug this in, this one right here is negative g. This one right here is negative h. Notice the minus signs cancel, and we see that you get a positive number here for the squared. So that's looking okay. And I think what we get is I'm going to pause. Somebody other than Esteban here, he just chimed in. What do you think? Is this looking good?
Shouldn't it be negative?
Why do you think it should be negative? Explain why.
It starts at 0 velocity and it has negative acceleration.
Yes. I would say it this way. Isn't it going downwards at the end? And I just said you have to assume there's a j hat on this, even though it doesn't have an arrow. So it makes sense. We always think about the plus and minus signs, always. And in this case, the minus sign is actually the appropriate root. Is everybody cool why that minus sign was there? I was trying to trick you. I failed. You guys are too good. That's awesome. What do you think? I hope you agree. The hardest part of these problems is not the algebra. It's getting the minus signs right. And it's all the minus signs mean is it's basically understand the true vector nature of these equations. Let me say that again. Understanding the true vector nature of these equations, right? This is a negative g in the j hat. This is a negative h in the j hat. V final y we expect to be negative in the j hat. And you never write the j hat here, but you're supposed to know that. And by doing this for weeks on end, hopefully that's starting to settle in pretty well. All right. And so for this part, okay, I think we can go to the solutions now because most of the rest of this is pretty straightforward. It's usually the first piece of a problem that's really hard. After that, it's on autopilot. So here's what we were doing. We just talked about this right here. And we just got that. After this, it's pretty easy to use this. You could do the unit check. We could do a common sense check. If you go from a taller building, h goes up. Well, your impact speed is going to go up if you use a bigger number for h. If you go to a different planet, say the moon or something, whatever, where g is a different value, it makes sense. For example, if you go to the moon, g is 1/6 of its normal value on Earth. And therefore, we get slower impact speeds on the moon. That's why everybody looks like they're moving in slow motion in those whole moon videos. Maybe I'll lecture in slow motion for the rest of the day. All right. Part B, impact angle. Here it is. And so there's a minus sign in there. You want to think about that. A note on this, I guess I should say this. Negative angles get tricky because we have to communicate with other human beings. Okay. So as part of a scientist's job or an engineer's job, you have to communicate with people. It's not enough to get answers. You have to communicate those answers with other human beings or a computer, right? If you want a computer to do some work for you. So it's really important, in particular with angles, that you understand, are you talking about the size of the angle or what not? For example, whoops. Let me bring this picture back up. You could say, let's say the number ends up being 53 degrees or whatever. Do I have the number? Let me just check. I don't think I gave numbers for any of this, did I? So we're not going to get a number in this case, but let's say this ended up being 53 degrees. So somebody might say, don't you mean negative 53 degrees? Sure, that's one correct way to say it. Another way would be, oh, you could specify 307 degrees, right? Just take 360 and minus the 53. So somebody else might say positive 53 degrees below the x-axis. Now, in general, you should know all of those things, but in particular for a Canvas quiz, usually I'm going to make you type in numbers between positive 180 or negative 180. So for this one in Canvas this semester, you would probably type in, say, negative 53 degrees for your number. Now, if you were doing a paper and pencil test like the final exam, what I would typically do is say, draw me the picture, label the angle, ignore the sign. So on a paper and pencil test, I say, draw it, ignore the sign, and just draw a triangle. That way I know which way it's going, and that takes care of all the ambiguity. But again, on Canvas, numbers between positive 180 and negative 180. I hope that's enough on angles for now. A couple of the next problems actually have numbers, so you could practice that. All right. I think, and then what was the last part? There was probably something else, probably the time to impact, right? Let's go see how that works out.
It's actually asking for the range of the ball.
Oh, the range of the ball. Oh, so they're asking for delta x. I see. So in this case, maybe I'll say one more thing. If we're looking for delta x, you usually need to get the time first and then plug that into that equation. And so in order to do that, let's go look here. So you could find the time using either the delta y equation or the v final y equation. And you can see both of those methods shown right there. So this is one way to do it. This is another way to do it. They both get the same answer for time. Then you just take that time and shove it in right there, and you get this weird result. And so that's not too bad. You could check the units, and it does work out. I'll let you do that on your own later. You've got these solutions at home. I know you could work through them. I think the thing that we should spend more time on is setting up the problem. So I'd like to go right to the next one. You should actually finish that one out at home and make sure you understand it. Okay. So that said, before I rush on to the next problem, any questions?
Yeah, I didn't get to look at what you just showed right now, but I wrote it down real quick. And so if you use the v final y equation, you end up with the zero. V final y minus initial velocity is 0, and then acceleration is 0. So how does that work?
No. AY is negative g.
Oh, okay.
Right?
See, I'm thinking because you're solving for
and so
delta
this,
x.
yeah, he's saying this goes to 0. Yes. So this is a lot like the cop and the speeder problem where we use the time from one of them and shove it into the other one. So we found the time using the cop equation and we plugged that time into the speeder's equation. And that's, yeah. So notice this is from the y equation. Good job there, Esteban. I think you answered your question, right?
Yeah.
All right. Yeah. Tricky, right? So again, you use one of these two to get t. Then you shove it into the x. All right. Good stuff. And that's a common strategy. We see now that you kind of have to do algebra to do some advanced physics problems, right? We're starting to get into more advanced problems. As they get more and more complicated, it's easier and easier to stay with algebra than it is to use numbers. You just got to believe me. You'll save hours and hours of work over the next few years by learning to do algebra first and numbers at the last possible second. That said, if you're taking a quiz and you see numbers and you want to plug them in right away at the first step for this course, that method might work. In general, that's a bad practice to succeed in physics over the next few semesters. So, but if you got to plug them in right away in this course, fine, and then push off some of the algebra to the next class, yeah. I would spend your time now learning the algebra well. That way in 161, when I'm kicking your butts, you're not having to learn the algebra, right? You could focus more on the tricky physics concepts. So that's the deal. This course is supposed to prepare you mathematically for a real physics course. All right.
So you can't solve time for just using the x coordinates, huh? Because of the
Yeah. So
you
the
have to use-
equation. This would be the x equation, right?
Yeah.
And we know that this goes to 0. And so we know this, whoops, this is a known, but this is unknown and this is unknown. Doesn't do you any good. I guess one thing you could do is you could take this equation, solve it for t, and plug it into one of those y equations and then solve for x. What I was suggesting is take one of the y equations, solve it for t, and plug it into this one, since this is already solved for x. And that's a little bit less work. It's not that you couldn't do it that way. Yeah.
But yeah, with just with the x coordinates, you couldn't solve for time.
No.
You need the
One
y
equation,
coordinates.
2 unknowns. Yeah. Yeah. Good.
Yeah.
Right on. All right. So let's take a look at the next question. And again, I'm not going to do all the work for you since I've already worked it all out in the solutions and I know you could follow it, but I do want to focus on the setup. So let me share screen and tell you what I want to look at here. Let's do this one. All right, so let's just take a look at this one right here. You got this ball, and all I want to do is get these set up, and let's just work to get part A, okay? So what is the setup for part A? Let's try this. I'll show you my board in a minute. Hey, Memo. Are you there, Memo?
Yes, sir.
Could you do a quick web search for me and look up Projectile FET HTML5 and put the link in the chat for them? That way they could check this after they're done if they want to see
Okay.
it. You know what I mean by that?
Yeah.
Projectile motion FET or something like that. Thanks, Memo. You're the man.
Okay.
Thanks. Okay. So we're trying to find the max height here. So what I did is I drew my picture and I labeled some point on there for the max height. Sorry if it's not perfect here. And we need our list of crap. Let's get to it. Okay. So in order to fit things a little bit better, I just called this H, V, and theta again, and I just put them off to the side. So H is going to be 10 meters. V initial, which was V, is going to be 19.6 meters per second. And theta, which is the launch angle, horizontal bar for a theta, is 30 degrees. So let's just go through it in order. Delta X, known. Oh, thanks, Memo. You're the man. And so afterwards, if you want to look at this, you could keep track of that FET there. And the idea is, I think I set this up. All these numbers you should be able to do in that simulation if you want to run it and see it on your own at home. Okay. So that said, what is Delta X? Somebody. Esteban's been doing a great job chiming in today, and I appreciate it. Let's give him a little bit of a break. I don't know who the other person was chiming in all day. You've been doing a great job too. So maybe let's see if we could get some other people to speak up. It's okay to make mistakes because it's on Zoom. No one cares. No one's ever going to watch this but you. So take a chance. Let's feel spicy. Tell me anything you know in here, anything at all. Somebody new.
Delta Y.
Delta Y. What is delta Y going to be?
Negative 10 meters.
No. And that's a good thought. That would be true if we were going all the way to here, right? This problem is asking, that's one of the things I wanted to look out for. So in this problem, we're supposed to get, what did it say? Max height. So part A says determine Y max. And I think that was Jacob, right? Do you agree that it's not going to be negative 10, Jake?
Yeah, because max height. Yeah.
Yep. So are you feeling brave, Jacob? What do you think delta Y would be based on the picture here I drew?
What
is delta Y going to be?
Well, we need to find max height to get delta Y, don't we?
That's right. Okay. What is, anytime you have a delta in math class, it's always what minus what. That's what I was going for. Sorry.
Oh, final minus initial.
Yep. Now, in this particular case, what is Y final for us? What did I call it?
Y max.
Yeah, and what's Y initial?
10.
Yeah, and are you okay that I just use H so it fits better?
Oh, okay, yeah.
Yeah, not that what you said was wrong. It's perfect, but just so I have room in these tiny little boxes on my tiny little whiteboard. Jacob, does that make sense to you?
Yes.
Okay, and how about everybody else? Does that make sense to you all? That would be delta Y, and this is the thing that we're trying to find right here, Y max. H is known. So basically, like I think what Jacob said originally is we're looking for delta Y. Absolutely. Because if we know delta Y, we figure out Y max. All right. Somebody else, anybody else, chime in here. Thank you for that.
So initial velocities, I got 19.6 cosine 30
for which one?
For X.
Yep.
And then the same thing but with sine for Y.
And so what I'm going to do is write it like this. So Esteban was saying he took these numbers and plugged them in and you get those numbers. That's outstanding. And since I have limited space on the whiteboard, and also because it's good practice to do problems algebraically, I would do it like this just to get the practice. So outstanding, good. Or in your problem, you could just leave it as V initial till the very end, V initial X. And then at the very last step, plug in that V initial X is whatever number he just found. So that was good. You stick in those two numbers, you get it. Excellent. Somebody else. Give me something else here.
We know acceleration in the Y.
Say again about, you said something about Y, acceleration Y?
Yeah, negative G.
Negative G. What's the acceleration in the X? Someone else.
Is it 0?
0. Nice job. All right, this is great. You guys are doing a good job. So wait a minute. Anytime this is 0, That doesn't change. And then at this point, is that all that we know?
Is
Let me
V final Y 0?
Nice. Why is it? Why do you know it's 0?
Because it stops and then goes down afterwards.
Yeah, so at max height, ding, 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 that's what tells us this. Not that the velocity is 0, it's this, but we see at max height, the velocity y component is 0. Yeah, and then I think the rest is all unknown crap. At this point, what do you do next? Write some equations, plug in the zeros, solve for something, reread the question, check the units, on to the next one. Any questions about that? I hope that's kind of making some sense. Let's take a look here. So that would get part A done. Let me see what the other parts were. Okay, so that would take care of this. I think we could also get this from that, the velocity at max height. Does anybody know what is the velocity at max height right now?
Well, in the y it'll be 0, but in the x it'll still be v sine or v
Yep.
cosine.
Yep. So whatever number you get there, it would be, now we got to be careful. The speed at max height is this number, and the velocity, you notice he was talking about the I and the j hat. So it would be 0 in the j hat, this much in the I hat. So remember, velocity is a vector. So, all right, good. What's the acceleration at max height? That's the next question, isn't it? Yeah. What's the acceleration at max height?
So it would be negative GJ.
Yep, negative G in the J hat, 0 in the I hat. Don't overthink it. Gravity doesn't turn off when you hit max height. There's still gravitational acceleration. All right, cool. And then let's see what that last bit is. Oh, X and Y. I think you could figure that out. Basically, get the X coordinate, and in part A, you got the Y coordinate. So there you go. All right, here's a variation on that one. You could do this one looks like it's the entire range. So that was the one I think Jacob was starting to do earlier. He was thinking about the entire range, and that's good. He could do that one. All right. 4.15, a good concept question. Everybody should do it. 4.16, another good concept question. Everybody should do it. Here's a question I discovered by accident totally messes with people. So at some point, you're going to be like, I got this. I think I'm awesome. And then you could try this one and see if you could still get it. And what this does is it exposes students to the following issue. So I want you to make sure you do that one at home. The idea is this. All of these problems have some things in common, and they all have some things a little bit different. What do they all have in common? Draw a picture, label them, list out some crap, and there's going to be probably 3 question marks somewhere in here. This is the other question mark right here, right? So in general, for these 2D motion projectile problems, we usually see there's 3 things you don't know. Well, there's no reason I couldn't say, well, figure out the acceleration on a different planet, or figure out the, what if I give you the final velocities and ask you to figure out the X and the Y or something like that? I don't know. But the idea is there's going to be 3 things in here you don't know. No matter what 3 things are unknown, you still write all the equations. You still write this list of crap. You plug in all the zeros and then reread the question to say, what am I looking for? And you solve for it. The rest is not rocket science. It's just algebra. You can do algebra if you practice, and you will get very good at your algebra in this course. Memo, do you have any? So Memo had this class. You had 110. You had 161. Memo, do you feel like sharing any comments, any reflections on this? Any advice you have?
On this stuff?
Yeah. You could put your screen on if you want. You don't have to, but yeah. Or any reflections you have that, or advice you would have for students learning this material.
Just doing the problem over and over again. That's what I do. I get it
Practice,
until
right?
I can fully, practice
What-
and try to fully explain the problem to someone who's having trouble on that problem. That's what I did.
So have a study partner or somebody that you work with and say, this is what I think.
Uh-huh.
I got you. And then, yeah, don't forget, people, you can work with Memo as a tutor. Don't forget, Memo, maybe throw your email in there again if you want. Maybe someday people will take advantage. Are they using it yet?
Yeah, some people have been using it.
Yeah. Do you have more times available that are unused?
Yeah, I think I'm just gonna do Thursdays, Saturday, and Sunday now.
I got you. So you can contact Memo. He'll tell you that in the chat. I think he's already working on it. So, yep.
Mhm.
So I saw somebody was saying something about buying a whiteboard. Okay, so Memo, I'm going to take you off the share. Thanks.
Okay.
Another trick you could do, if you have a glass sliding door, you could write with whiteboard markers on your glass sliding door. Just don't use Sharpies and then blame me, all right? All right. But so yeah, if you need a whiteboard in a pinch, you could try and use a window or something, or a glass sliding door might work. Kind of depends on the lighting that you have, and yeah, so that might work. Yeah. All right. Let's take a look at right on. Cool. Yeah, this one's really nice because it rolls and I can move it. It's perfect for class. The only thing I wish is that I wish it had that rotated aspect ratio so I could use the whole width of the screen, but what are you going to do? It's better than nothing. All right. So, all right. These last two problems are going to kick your butts. So make sure you do them and don't feel upset when you get your butt kicked. All right. But try to learn from it. This one, especially, let's just leave it at that. Next, I want to go on to 4.18. Let's say you have a watermelon thrown beneath the surface of a swimming pool. Now, you may be wondering who would actually do this. Of course I would. This is something I used to do in grad school, and we would throw watermelons under the surface and watch them. This problem is not a perfect model, but I do want to point out something very different than all the previous ones. Look at this. We're going to assume a sub x is -2 and a sub y is 4 based on these coordinate systems. Okay. So now a sub x is not 0. This is a problem that I choose to call non-standard, meaning it's not a projectile where ax equals 0. It's not like the techniques are any different. Everything we do is exactly the same, only ax is not 0. And let's see what happens and what the consequences are. So go ahead and write this up on your paper. I'm going to write it up on mine and we'll compare. And remember, at any time, if you don't like, or if you have a question and just want to ask somebody and you don't want to talk to me, remember you can talk to Memo all through class and chat or whatever. What is this, 4.18? Got a watermelon. I think that's all the info. Okay. So this is what I drew. Okay. So sorry, there's a little glare there, whatever. So the idea is you got this watermelon, it's going to be going down and back up. And what are we supposed to find? Geez, what are we looking for? It says final speed and heading as it resurfaces. What does that mean?
So it wants to know the resultant vector, I guess.
Yeah, exactly. In polar form, magnitude and direction. Excellent. So according to these, what symbol is final speed?
VF.
That's VF. And then what would the heading be? What's a good name for that heading or direction?
Theta?
We've already used theta for the launch angle.
Theta final.
I would say, okay, theta final or
okay.
phi. So, yep, and you're right. So I would call it phi. And so just to make sure you can see all that before we get ahead of ourselves, I'm going to scoot this extra close just so you can see it. Just making sure you can see all the pictures here. So we have final speed. There's the final velocity in the x, final velocity in the y, the angle, phi. Together, these two make the final velocity. That's what Jake was saying just a second ago. These two is the magnitude and direction of the final velocity. This is the magnitude and direction of the initial velocity. All right, so now I'm going to make my table. And I'm going to plug in the easy ones that are right here. Because I'm running out of room, I'm not going to include all the sig figs. Got that. Let's go through. Somebody tell me something we know now. Anybody that you want, just chime in at will here. You can do chat, you can do unmute, whatever you want.
We know both initial velocities, so.
Yep. How would I get v initial x? You don't have to tell me the number. How would I get it?
It will be let me see. So.
Is it adjacent or is it opposite?
Adjacent. So it'll be v cosine.
Excellent.
30.
And then what would v initial y be?
V sine 30.
Nope.
It's a negative V sine 30.
Close.
Ooh, nice.
You like that? You see, I'm trying to trick you. This one,
Wait.
so you can see that every minus sign is precious. It's minus v sine 30, because think about it. Oops, let me call that minus v sine theta. Theta, in this case, I specified a positive number, right? So you have to know it's initially going down. The assumption was upwards is positive. So here the initial has to have a negative, right?
Wait, what did Esteban say? That wasn't right.
He said
the same
negative.
thing.
He said the same thing as you, but just put in the negative.
Wait,
Maybe
so
you-
how's that different from what you put down?
I think maybe I misheard, but I thought I heard you say v sine, but the answer was negative v sine, right?
No, I said negative V sine.
Yeah, right. So that's what you said, and maybe all right. I think we've got it.
Okay.
Everybody's on the same page. Everybody agrees
Okay.
this is right. So I just wanted to point out that it's important to get that minus sign there, and that's all I'm trying to stress. I think Esteban said it right, and yeah, we're good. And Jake, if you said that right, I apologize. My bad. Okay, so do we know anything else?
Okay. Well, if we were to, the final velocity at the end of the curve is 0. If we were to separate it that way.
Nope,
But I
that's
don't-
not
I don't-
true.
No. So it,
Let me write this word here just so we have this, so we know what we're talking about. We're talking as it resurfaces, right? Isn't that right there? Is the velocity
Yes.
0 there?
no,
Is it 0 in the y there?
no.
Is it? Yeah, it's not 0 in anything there. So that's not good. That was a good thought. So it's not these. So in fact, I don't think we know either of these. Right? Wait a minute. Wait. Let me ask you this. Can't I just say V cosine here?
No.
Aren't these two always? Yes, you're right. We can't say these are the same anymore. They're always the same if that's 0. Because this is non-zero, we can't use these two are the same anymore. So that's why I put a question mark there. If you're wondering, wait, how come it's not just V cos? In this problem, AX is non-zero. Shoot, we're in trouble. But clearly we must know at least one more thing here. What is it?
Is delta
So,
y
I mean,
0?
Delta Y is 0. You start and end at the same height. Sweet. So that is going to get us, we're going to learn something out of that. I think at this point, you could probably use this equation to figure out the time. And once you know the time, all the rest can be figured out. So I don't think we know this, and I don't think we know this. In this case, it looks like there's actually 4 things we don't know. This is a lot like a cop and the speeder, but where both of them have an acceleration. And so instead of having only 3 things you don't know, we get 4 things you don't know. So what would you do next? Write some equations, solve for some crap. Do you want me to write out the equations, or do you want to do another setup? It's up to you. Just be honest. Whatever you want is what I will do.
Another setup.
Sorry, you cut out there. My bad.
Another setup. I think I don't know. I feel comfortable with the equations. It's just getting all the information sorted is where I struggle.
I think this is the hard part. Agreed? Figured
Yeah.
out whether you have to get. So let's try the next problem, and I'll let you guys do this problem on your own because the rest is just algebra. It's now, don't get me wrong. You'd better practice your algebra because if you're bad at algebra, you're slow, and then that eats up your quiz time. So if you don't do the algebra at home, you're gonna lose these quizzes badly. But if you do it at home, you're gonna be so fast, you'll be like, oh, I got this. So it's really night and day whether you practice or not. Okay, let's do the next setup. By the way, are you guys cool with this where I kind of hide my screen for a minute and give you a second and then show it? Or would you rather I just have my screen on while I write it up? What do you want? Is this
It's good to hide it so we can see if we're doing.
so you
the
could
same.
try it yourself and then I show you?
Yeah, I agree.
It's just kind of, it adds a little bit of a puzzle element and slightly more interesting, right? Okay, so if that ever fails, guys, just let me know and I will change the way I teach because this sucks online. So, all right, that said, it seems like it's as good as it's gonna get. So let's try another one. Oh, let's get a drone involved. Let's try 4.19, the drone. All right. So here's one where, well, let's not say too much. Go ahead, write what you think, and I'll write what I think.
So acceleration in the x is negative g over 2.
Beautiful.
And then y would be 2g.
Yep. All right.
I think we know the initial, but I'll see if someone else maybe can.
Okay, sure. Sounds good. What do you think? Anybody else want to give it a shot? Something else that we know or don't know?
V initial x is V0.
Okay. What's V initial y?
0.
Nice. Okay, because it's all horizontal. Good. And then what else do I know or not know? Do I know the delta x's? What do you think? And the delta y's?
No, I don't think we know those.
I agree. So how many unknowns do you think we have in general for this type of problem usually?
5.
4. So that means there should be one more thing you know. There's always one that's tricky. And remember, without it, you basically can't do anything.
Wait. No, never mind.
What were you thinking? Go ahead and try it. And if it doesn't make sense, I'll be like, oh, yeah.
I was going to say v final y, but there's an acceleration, so I don't know.
Yeah. Okay. So you're right. We don't know that. What is the other unknown? What is the other thing that is known?
Is it that VFX is 0 because we're looking for when VFX is less than 0? At that point is when it's going to be turning left.
Exactly. Right? When does it reverse direction? Think about it. When something reverses direction vertically, we've been saying V final y equals 0, right? When it's reversing direction horizontally, we say ding, 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 ding. Isn't that cool? What do you think? All right. I'm going to try and find something else for you guys really quick. So that was good. And then at this point, you could do algebra. So I'd rather just keep hammering away on some more questions. I have another secret source of questions here. So at this point, I think you could pretty much do the rest of that page, everything up to 4.21. 4.21 is a little sneaky. You might want to actually do that one carefully. It's got numbers, but students blow that one. Maybe it's the aerodynamic taco factor. And then what are we going to do next time? We're going to do relative velocity. So we're good. I can do this. Let me see if I can show you another spot here. Let me see. I'm going to go to here. And then let me move this just a second. So I go to robjorsted.com, physics 110, Yeah, aerodynamic taco factor. One of the problems has an extremely aerodynamic taco. So there's no air resistance on that taco. I think I wrote that one with that space thing was falling back to Earth, and Taco Bell was going to give away $1 million of tacos if it hit it or something. Whatever. All right, so I'm going to look at just in case you're wondering, I went to robjorsted.com, just walking you through this. I clicked Physics 110 exams. Let's go look at an old exam question. What happened to it? Let me see what I did last year. Let's see, we're in chapter 2, right? 2D motion. Let's just check this one here. Oh, that one kicked everybody's butts. Here's one. Okay, let's give this a shot, and I'll make this a little bigger so you can see it. Memo, if possible, could you find the link to this thing and stick it in there? Oh, actually, I could probably just copy this link, couldn't I? That's probably easier than making Memo do the work. Except I'm slow. There's the test I'm looking at if you're curious. We're looking at question 5. All right. You can see that this is test level difficulty now. I'll catch up with you. Try and write down the list of knowns and unknowns for this. Just trying to make some space so I could see things. There we go. So we have some coordinate system here. Okay. So we got a hovercraft we're looking at above. Looking for got it. Okay. That's how I interpreted the question. You got your own way of doing it. You're initially 2.22 meters north of the origin. You're moving south with this acceleration. Let's go ahead and plug in all the knowns and unknowns here. It says, I think we're asking for time. Hey, okay. Not every question is going to have time as an unknown. Every once in a while, time is a known. That said, all right. Somebody give me something. Give me any one of these rows.
Or you got acceleration.
Okay, do
on
that's Esteban. Give me the acceleration. Go for it.
6.66 meters per second going east. So that's positive.
For which one? X or Y?
Well, that would be for X. We're going east.
Okay, how
Right?
much in the Y? What's that? I couldn't hear you.
The Y is 4 point. Oh, we don't know the acceleration for the Y yet.
We do.
We do? Oh, okay.
Because in this case, it says it's accelerating to the east. If you're accelerating due east, how much are you accelerating north or south? None. So again, we see that almost all of the problem is easy except for one little unknown or known. There's always something you have to get from the words. Esteban, did that make sense to you why this is 0?
Yes.
Going east, that'd be like saying moving horizontally. If I say you accelerate horizontally, that necessarily implies none vertically. Okay. All right. Somebody else. Esteban's done. I think it was Jake. You were going to say something, right?
Yeah. So we know the V initial Y is negative 4.44.
Yeah. All right, Jake. What's X? What's the initial in the X then?
I think it's 0.
Exactly. It's the opposite of that last one. Here, accelerating horizontally implied vertical is 0. Here, moving south implies east-west velocity is 0. Nice. All right. Do we know anything else?
V final Y is negative 4.44.
Oh, cool. You're right. Nice job. I didn't even notice that at first. That was really cool. If this is 0, don't these have to be the same? Really good. I love it. Excellent.
And then delta Y is negative 2.22.
You guys are kicking ass. I love it. What's delta X? Known or unknown, do you think?
Unknown.
Unknown. Whoa, look at this one. Isn't this weird? In this case, all of the unknowns are on the X side and none of them are on the Y side. That's kind of weird, isn't it? Whatever. Remember, the time is actually a shared one. So technically there is one unknown over there too. What do you think? And then you just do some algebra. Should we try another one? Or are you guys beat? We got 5 minutes. We should do another one. What do you think? Or I'll pause for
let's
questions.
do one more.
Yeah, I think, and then I think you're starting to catch everything. You guys didn't make a single mistake on this one. That was good. This was a tricky one that you had to kind of imply, but now that you're seeing that, you guys are good. Let's try one more. Let's pick the other test. So I think that was B. Let's see what the other test had. Oh. Let's try this one. All right. I'll catch up. Running out of room. Oh, you already got that? Oh, cool. Thanks, Jake, for getting that website in there. I was just about to post it in there. Sorry about that. All right. This is linked all in the Canvas modules too. Somewhere, if you look for the practice tests in the Canvas modules or whatever, you could find that. Or if you have questions, you can say, Memo, where do I find these? And Memo knows where everything is. So, all right, let's get these list of knowns. We got 2 minutes. You could do this. Somebody give me something. We're looking for the time to cross the y-axis. Okay, go for it.
So time is unknown.
Time is unknown. Got it.
Our initial velocity in the x would be negative 1.11 meters per second.
Yep. What's the initial velocity in the y?
0.
Yep. If we're moving left, you're not moving up and down. Next, what's the accelerations in this case?
So the acceleration in the x is 0. And then in y, it's positive 4.44 meters per second squared.
All right, so let's let somebody else have a chance. Oh, that's squared, isn't it? Meters per second squared. Sorry about that. All right. He cleaned out the easy stuff. All right. What else do we know? Anybody other than Jake?
Delta x is d cosine of theta.
Close. So close.
Negative d cosine theta.
Negative, right?
Left.
Because it's going to have to go to the left Did that make sense? Whoever that was, who is that?
Oh yeah, that makes sense.
Was that Jose?
Yeah.
Right on. Okay, so he's absolutely right. This should be negative d cosine theta. And we know both d and theta right there. How about delta y? Known or unknown?
D sine theta, positive.
Not
It's
not
negative, no? Because
necessarily.
you're going down.
I don't know what it is. Think about it. Just because you get over to here, right? You could be going like this. Your change in y might not be this distance. This is d sine theta. There's no reason to think maybe actually you're going to go something like this. I think you're going to be accelerating upwards. So maybe you'll go like this. There's no reason to believe the vertical displacement is the same thing as d sine theta. Agreed?
Oh, yeah, that makes sense. Good
If
point.
I was asking for something like if this had a negative acceleration, I said time to hit the x-axis, you would have been right. But here, we don't know what this is. It's not d sine theta. All right. So how about v final y? Do we know that?
No.
Nope.
We also don't know v final x either.
How about v final x? Nope, we do. Ax is 0. Don't you love it? It's so sneaky. It's like,
shoot.
right? Yep. And that's probably a good spot to end today. So I'll make sure I send this link to the earlier class because I think I did a better job than during their lecture. I totally spaced out and missed the first 5 minutes of lecture today. And so I was all combobulated. So I apologize for that earlier class. What do you think? I'm going to stop the live share unless you guys have a question about this, and then we can go to office hours.
Could you explain exactly why delta y is not d sine theta again?
Yeah. So take a look. I don't know how long it's going to take to get over here. Agreed? Do you agree with that, Esteban?
Yeah.
And so I do know this thing is initially moving to the left, but accelerating upwards. That means it's going to be an upwards parabola. Are you okay with that?
Okay.
And then there's no reason to think that this will go upwards. Like, let's say, what is this distance? D, could you just tell me what D sine that is? What is D sine 66? Did somebody put it in the chat for me there?
It's 3.04.
3.05.
3.05 meters?
Yeah.
And then this distance right here is how much? It's going to be D cosine that.
1.32 meters.
Okay, and normally we keep some extra sig figs, but for now, this is good enough. You always want to have extra sig figs on these numbers so that your final answers are correct to 3, right? So this is true in Canvas. Make sure you keep more than 3 when you're doing all your intermediate work. Otherwise, you could get screwed by Canvas and be off in the 3rd sig fig and miss it. That would suck. So keep at least 4 when you're doing math, maybe 5, and then round it to 3 at the end. So now here, you can find the time, and we know that this one, the horizontal, should be negative 1.32 meters. So that's going to be negative 1.32 meters. But there's no reason to think that this distance here, the amount you go up, should be that. Agreed, Esteban?
Okay.
Because, right, the time it takes to get over here will give you this. And in fact, delta y should equal, because v initial is 0, it's going to be 1/2 a sub y t squared, right? And there's no reason to think that with this acceleration, even if it was, what if I change this number? There's only one possible acceleration that could ever make delta y exactly equal that. And to have that happen would be a crazy fluke coincidence. It's not saying that it's impossible to be that number. It's just exceedingly unlikely to be that number. Is that better, Esteban?
Yeah, a little bit. I'm gonna.
You want to
think
look at the
about it.
solution really quick?
Sure.
I've got the solution right there. So remember, if you guys like these test questions, the solutions are right next to them. That was A, right? This shows you the distribution for a typical test on paper. So in case you're thinking like the quiz grades are horrible, well, they're always horrible all the time. So yeah, anyways. What was it? I think it was this one. So you could see regarding the sig figs there. Give me a second. You could see I kept extra sig figs just in case. Oh, and look here carefully. Delta X is this. This was X initial. This was X final. And so that's how I got delta X. Just a sec. Later, Memo. Later, Memo. He's out of here. So, all right. So now, take a look right here. That's how I got the time. Then I took that time and I plugged it into here. And notice when I did that, I got 6 meters, which is totally different than 3.
So sine theta still get, so the d sine theta is just initial y.
That's
Right?
right. That's
Okay,
right.
so that's why it doesn't. I was like, wait, that doesn't make. I don't understand. I don't get it. I was like, that has to be something.
It is. It's initial y, but it doesn't tell you delta y.
Yeah,
Okay.
got it. Okay.
All right. Now I'll probably stop the live share or whatever you call that, unless there's any other questions while I've got this open. All right, let's stop.